Hi guys, tonight we're going to talk about wave action. It goes with Chapter 14, Section 3. Okay, so how waves form. Basically, wind blows across the water and it makes ripples in the water. And as those ripples get bigger and bigger, and if the wind blows harder and harder, then those piles of water get larger and larger, which creates larger waves. Now, the only part of the wave that moves forward is the energy. So if you can picture a raft in your head that's sitting on the ocean, like if a person is floating on a raft, that person doesn't ride one wave all the way in from out of shore onto the sand. They'll go up the wave and then they'll go back down the backside of the wave, and they'll go up the wave and then back down the backside of the wave. So the actual water particles only go up and down, and they actually are moving in a very small circle. They do not actually go forward. Now, that'll change as you get closer to the shoreline and as the bottom of the water starts to shallow out. Now, the deeper the water particle, the smaller the circle that it moves in. So if you look at this diagram right here, at the top, you notice that that's a very large circle for that buoy. And as you go down, down, down towards the dotted line, those circles get smaller and smaller and smaller. So that buoy goes up the front of the wave, and then it goes down the back of the wave, and up the front of the wave and down the back of the wave. If you get below that dotted line, the circular motion stops. So if you're a scuba diver and you're up top up here, you'll feel a lot of wave motion. But if you can dive down deep enough to get below that dotted line, you won't even know that waves are moving on top of you. Those could be hurricane-sized waves on top, and you wouldn't feel any movement at all as long as you're below that dotted line. Now, the bigger the waves are, the lower down that dotted line is going to be, though. So here is the motion of the waves all at once. And again, you'll see the yellow dots there are showing you the different particles as they're moving. So you can just pick one of the lines of particles. And as you get to the top, notice the size of the circle. Not if the energy was moving, or if the water particle was moving forward, then that yellow dot would go forward with the wave, but it's not. It's going up and down in a circular motion. As you go down, that motion gets smaller and smaller and smaller. So you would see that the red dotted line would be right here at that bottom yellow circle. But that's where the motion stops. Okay, so the anatomy of the wave, that means parts of the wave. So you have this diagram on your notes page. The very, very top of the wave is called the crest, so I'm pointing to it right here. The very bottom part of the wave is the trough. You have the distance from crest to crest, or it could also be the distance from trough to trough, but it's called the wavelength. And then you have the distance from the trough, which is the bottom of the wave, all the way to the top of the wave. That's called the wave height. Now, two terms down here. Wave frequency, that's the number of waves that pass you at a given time. So if I'm counting, if I'm standing right here in the ocean and I'm counting, I give myself 30 seconds and I start counting how many waves go by, then that's the frequency. So if 10 waves go by in 30 seconds, then I have a frequency of 10. If 30 waves go by in 30 seconds, I have a frequency of 30. So the higher the frequency, the more waves are coming at you and the closer they are together. Obviously down here, if you get to wave height, the higher the wave, the more energy or strength it's going to have. Think logically about that. If you're standing in the ocean and you have a 2-foot wave hit you, it might move you around a little bit. If you have a 10-foot wave that hits you, you're going to feel a lot more force. So that gets us to the different types of waves, and we're going to start with what are called breakers. So out here with the deep water waves, you see we have just kind of these bulges, but as the ground, the seafloor starts to shallow as you get towards the shoreline, it pushes the water up. Okay, this water, as it's moving forward at this point, because when it starts to shallow is when the water actually does start moving forward, not just the energy but both. The water actually gets taller and taller because the bottom is pushing up and getting shallower and shallower. In addition to that, because the water's moving towards the right, to where it's breaking on the shoreline, you have friction down here at the bottom. So the bottom of the wave slows down while the top keeps going at the same speed, and eventually the waves get so tall and the bottom moves slower than the top, so it literally topples over. It's like your feet not going as fast as your upper body. You would eventually tip over if that was the case. So those are called breakers, and you end up with that white cap that's on the top right over here, and then it breaks onto the shoreline. Okay, switching gears, we have longshore currents, and these are waves that come in and hit the shoreline at an angle. So as it hits, it actually moves the sand up the beach, and it'll deposit the sand in other directions or other places. So it can be a problem in areas where it happens a lot because you get a lot of erosion going on. So if you have a house or something that's right along the shoreline and all that sand starts to wash away, then you could lose your beach. So a lot of the popular beaches like Destin and Panama City, they actually have different barriers that come out, like piers and things, to try to block some of that water and prevent some of that erosion from happening. Undertows, you always hear about these, especially if there's a storm coming. It's quite simple. The water comes in as the breakers and rides up onto the shore as usual, but then it flows back down and you get this current of water that's going back out to sea at the same time the top part of the water is coming in. So it can actually pull you under and pull you back out into the ocean. So you have to be very, very careful when you hear about an undertow. All right, open ocean waves, these are the ones that are way out in the ocean. So if you're on a cruise ship, these are the two different types that you're going to see. So we have the white caps, which are formed by heavy, heavy winds, usually when you have a storm, and it basically makes breakers that are out in the open ocean. So very, very choppy, and you can imagine that being in a cruise ship out here with these waves is going to be a lot rougher than if you're on a cruise ship out with swells, which these are generally what they look like on a calm day. So nice, easy, big, wide waves that don't cause as much of a problem. Okay, so you've seen these before when we talked about earthquakes. They are tsunamis. So something has to happen under the water. In the scene that you're seeing right here on the screen, you have an underwater volcano that erupts and it pushes up the water. But it can also happen with earthquakes when the reverse faults move and you get uplift of some of the ocean floor and it pushes up the water that's sitting on top. And that water moves inland, and as it gets towards shallower water, it gets taller and taller and taller, and eventually it topples over and you get this giant flooding from the tsunami. And last but not least, we have storm surges. So this is when the water just naturally from the wind of the storm blows into a giant pile. And so you have what is a big bulge of water, and as it comes inland, it literally surges over the shoreline and floods the inland area. So you can see on that picture that you're watching how it just kind of surges in and floods. It's not a big wave per se, it's just more of a bulge of water that overflows. Okay, make sure that your notes are filled out because I'm going to be looking for those tomorrow. Have a good night.